Greetings, math fans. All right, so today is day 6, and we're going to talk about something called one-to-one functions. Okay, I like to abbreviate it as 1-to-1, just a little bit faster. Now, as I'm making this video, it is January 31st of 2011, and we are less than a day away from this enormous blizzard that is heading this way. It's supposed to be one of the most brutal storms, winter storms to hit Chicago. I don't know, in a decade or until really like a century, comparable to something in the 60s. But the storm is supposed to hit February 1st, tomorrow around 3 o'clock, and it's supposed to dump, they said, between a foot and 20 inches of snow on Chicago. So, anyway, just kind of a little detail there, because who knows, maybe sometime somebody might be listening to this video later, and it could be nice and sunny. So, all right, so let's define one-to-one functions. It's basically each output has exactly one input. Okay, each output has exactly one input. And let's just talk, in other words, just to give you a little bit clearer definition, you'll never have the same output for any two inputs. Okay, you'll never have the same output for any two inputs. So real quickly, let me just give you an example as what I'm really talking about here. In terms of coordinates, an example of a one-to-one is if I give you like 1, 3 and 2, 4 and 5, 5. All right, so that's an example of a one-to-one function because each input has exactly each output has exactly one input. All right, here's an example of a not one-to-one function. Okay, that would be giving you like 3, 4 and 5, 4. Now this is a normal function, right? Because the x value doesn't repeat, but it's not a one-to-one function because, as you can see, if I put a different input, what do I have? I get the same output. Okay, and so that's bad. That's not a one-to-one function. All right, so what about just an equation? Example of a one-to-one function would be f of x equals 2x. Okay, and here f of x is equal to 2 to the x power. Okay, you'll never have with every input, you're never going to have the same output. Okay, so I can put any value I want for x. It's always going to be f of x is always going to be something different. All right, and then here's an example of not one-to-one. That's going to be like f of x equals x squared. Okay, it's a great example because if I do, for example, f of 2, that's my input, I get a 4. And here's another input, f of negative 2, I also get 4. So this is not one-to-one because you have the same output. All right, now how do you do this? What does that kind of mean? Well, if I actually graph it, let's just graph y equals x squared. Isn't it kind of like this? And do you agree that if I put an x in for an input, let's say x is equal to whatever, I don't know, put that value in, I can take negative of that value and I get the same output, I get the same y value. So this is not one-to-one. So how do you test that? All right, well, basically what you do is you do the horizontal line test. I know you guys are used to the vertical line test just to see if it's a function. Well, to see if it's a one-to-one, you do horizontal. Ooh, I kind of missed that point. Okay, so if it hits it in two places, then it is not one-to-one. All right, so I'll write on here, use horizontal line test. Okay, and that's for graphical test. All right, so pretty easy, right? Okay, so let's talk a little bit about something else called inverses. Okay, so a little verbiage here. Since each output comes from one input, a one-to-one function can be reversed to send outputs back to get the original inputs. Okay, so again, a one-to-one function can be reversed to send the outputs back to get the original inputs. That's why it's a one-to-one function. One input, one output, and then you can reverse it. Okay, and that's what this is. So basically, this function right here that you reverse is, so the reversed function is called an inverse function. Okay? So really, so given f of x and g of x are inverses of each other. So if I told you that f of x and g of x are inverses of each other, that means f of g of x, if I plug that function into the original function, okay, I will get that equal to x, which is your original input. Same thing if I do f or g of f of x. That's the same thing. It's also my original input. Okay? And close parenthesis. So that's important. That has to be true. And this, I'm going to highlight this here. This has to be true in order for them to be true inputs, or to be true inverse functions. Okay? And that's going to be what our test is. And if, let's write this out here, if f of g of x or g of f of x, so if I do that, if that's not equal to x, then not inverses. Just a good check to see if these are inverses. Okay, so let's just do an example here. Clear this out. Okay, so your example is r f of x is equal to 5x and g of x equals x over 5 inverses. Well, let's do f of g of x, right? Just other notation. And so I'm going to plug g of x into that x, so it's 5 times x over 5, which is, hey, equal to x. How about g of f of x? Well, I'm going to plug f of x into g of x, so I get 5x over 5, which is x. So the answer is yes. Sweet. Okay. Here's another example. F of x equals x and g of x equals 1 over x. Are they inverses? Well, let's check it out. F of g of x, okay, is, again, I'm going to put that 1 over x into x, and I get 1 over x. All right? Well, right off the bat, that's not equal to x. So the answer is no. And don't get fooled by saying, oh, well, let's do g of f of x. Because I put f of x into that, I get 1 over x. Now, these are equal. That's great. But neither one of them, or they both have to be equal to x, and they're not. So the answer is no. Okay, those are not inverses of each other. All right. Basically, if a function is 1-to-1, then it has an inverse. Okay? If a function is 1-to-1, then it has an inverse. So, here's an example. Okay, well, of course it does, right? Again, graphically, you can see that it's a 1-to-1 function, passes the horizontal line test. And this is just kind of a repeat of what I did before a little bit. Okay, but, no. Right, crosses it 3 times here, so this is no. This is yes. All right, so let's keep going here. Finding inverses. Oops, I kind of spaced that out here. Finding inverses. All right, first of all, let's talk about notation. You guys probably already know this, right? Inverse is just like we did inverse sine. It was sine to the -1. It's count as anything with a function, f to the -1. Please, as you know, sine to the -1 doesn't mean 1 over sine, okay, which is obviously 1 over sine is cosecant, right? This is not equal to 1 over f of x. Okay, you guys probably know that already. Okay, that's important. I just want to mention that. All right. This is actually, so I'm going to just cross this out. That is what an inverse is. Okay. All right. So here are your steps to find out or to find the inverse. You basically interchange x and y. That's the first step, and the second step is solve for y. It's really pretty easy. So here's an example. F of x equals 2x minus 3. Well, I'm going to write it as y equals because we want to interchange that. So 2x minus 3. And then to find the inverse, it's x equals 2y minus 3. I just swapped the x and y. That was our first step. And our second step is solve for y. So 2y equals x plus 3. Add 3 to both sides and divide by 2. So y equals 1/2 x plus 3/2. Okay? That's the inverse function. And then, of course, I can verify it just by doing plugging that back in, right? Saying this is my f of x, and we can call this g of x if you want. And let's do f of g of x. So if I plug the g of x into the f of x, I get 2 times 1/2 x plus 3/2 minus 3, which is x plus 6/2 or 3 minus 3. Hey, look at that, equals x. Sweet. And I can do g of f of x. Plug the f of x into the g of x, I get 1/2 times 2x minus 3 plus 3/2. So I get x minus 3/2 plus 3/2. Hey, look at that. Equals x. So they both equal x. That means they, just to kind of verify that they are inverses. Yes. All right. Pretty sweet. Okay, so a couple important things here. Write these few things down here. The domain, and I'm going to put a star next to it because I think, or an asterisk, I guess, because this is important. Everything's important, though. I guess I could put a big star next to everything. Okay, the domain of f of x equals the range of the inverse. Okay, and the range of f of x equals the domain of inverse. All right. So let's look at our last example. We had f of x is equal to 2x minus 3, and inverse. So f inverse of x is 1/2 x plus 3/2. Okay, so let's just set our domain for the first function. let's say our domain is, we can do whatever we want, but let's say it's between 0 and 2. Well, do you guys agree that our range then is going to be, if I plug a 0 in there, I get -3. And I plug the 2 in there, I get 4 minus 3 is 1. So that's my domain, and that's my range. Okay? Let's plug in, if I said, right, the domain is the range, and the range is the domain, let's just say then the range is between, the domain. The domain is between -3 and 1, right? Let's kind of just put that in there. And let's plug those values in. And if I put -3, so it's 1/2 times -3 plus 3/2. So it's -3/2 plus 3/2 is 0. Sweet. And then let's plug the 1 in there. 1/2 plus 3/2 is 4/2 or 2. Hey, look at that, man. Right there and there. Okay, so the domain is the range of the inverse, and the range is the domain of the inverse. Okay, so they just kind of swap. All right. Now I'm going to show you something where we're going to be using parametrics. And so this is using parametrics to graph inverses. Now this is, and I'm going to put a couple of little arrows there. And I'm going to say very useful, and I'm going to underline it. You know what? I'll put a box around that because it's really important. It's a very nice box. Okay. And this is, I'm going to put here super easy as well. Wow, a lot of great words here. Okay, so this is the deal. I have y is equal to 2x minus 3, and I want to find the inverse of that. So truly what I'm doing is I'm swapping, and I'm saying x equals 2y minus 3, right? I'm kind of swapping it out. But, well, I mean, here, yeah, I can solve for it and everything, and it's, you know, it's pretty easy to do, right? We just did that. But why not use our graphing calculator? So what I'm going to do is my parametric, if I do y equals 2t minus 3 and x equals t, do you agree that's how you can put that turn into a parametric, right? That was the way I showed you. That's really easy. All right. Well, if I wanted to find the inverse of it, then what I can do is, instead of saying this, how about if I say y equals t and x equals 2t minus 3? Very interesting. This, math fans, that's my inverse. Okay, that's how easy it is. You literally just swap the value of x and y, and that's exactly what I did. I made y equal to t instead of x, and I made x equal the 2t minus 3. Okay, so parametrics is awesome for sketching inverses. Now, the one thing I need to also tell you, since it is it's a one-to-one function, it is going to be symmetric about y equals x, right? Okay, because our input is going to be the same, one input, one output. Okay, it's going to be symmetric about that. And let's actually graph in the graphing calculator now. So let's bring that up. All right, so let's enter in the parametric y equals, and you know, for the first one we're going to do x equals t, and y equals 2t minus 3. So 2t minus 3. And then we're going to graph the other one, the inverse of that. So I'm going to say x is equal to 2t minus 3. And y equals t. Okay, and let's graph this baby. And there it is. And look at that. If I actually want to show it's symmetric about the y-axis, you can kind of see if I draw a line here, right? It's y equals x. I said y-axis is symmetric about y equals x. I can put, how do you input a y equals x into this? Well, can't you just say they're both equal to t. All right, that would make y equal to x, wouldn't it? So let's check it out. Oh, yeah, there's that middle one. So you can see it's symmetric about y equals x. Okay? It's actually kind of interesting. But now you're like, well, that's not a big deal. Come on, Mr. Curves. I mean, that's a pretty easy equation. Well, what happens if I give you something a little more brutal? So here, I'm going to go back to my document here, and let's delete this here. And let's do, I'll put it over here so we can see both that and the calculator. Y equals 2x squared minus 5x minus 1. Okay, and I want to look to see about its inverse, so I am going to set y equal to t, and I'm going to say x equals 2t squared minus 5t minus 1. So let's put that on our graphing calculator. And we're going to do x equals 2t squared minus 5t minus 1. Y equals t. Clear the rest of these guys out. Okay, and if I graph it, that's what it looks like. Okay, that's the inverse of that. Now, is that really truly the inverse? Well, is this a one-to-one function? Nope, it's not a one-to-one function, right? Because what does the original graph look like? Y equals 2x squared minus 5x minus 1 is actually a parabola. Not an inverse function, but it definitely is. If I want to swap the value and kind of check it out, I can do that to test it out, to look at it, see what it looks like. Okay. But that's kind of how you use parametrics, is actually just by plugging it in and just swapping the values of x and y. All right, that's kind of it with that. Just like I said, I just want to show you the calculator a little bit. We're going to use this in 2 seconds here. Okay, so let's delete that and let's practice solving. This is just part of this unit here. Solving exponential problems. We're going to actually use manual and graphing calculator, okay, because you need to know how to do that. So here's the first one. 2 to the x equals 10. All right, you guys already know how to do this, because basically what you do is, with the graphing calculator, we're going to get an approximate value. And manual, we're going to get an exact answer. Or we can get an exact answer. All right, so let's do the graphing calculator. Remember what to do? You move that 10 over, so we get actually y is equal to 2 to the x minus 10. And then we're going to graph it. And so in order to get full credit here, math fans, you need to show all steps. So you need to tell me what you're going to push on there on the graphing calculator. Okay, so let's actually go to the graphing calculator now. And we need to actually go into our correct mode, right? I need to go into function, not parametric. Hit enter. And then you go y equals, and it's going to be 2 to the x minus 10. Okay, and then let's zoom 6. All right, and of course is where the value of y equals 0, which is your x-intercept. So we're going to do second, and again, these are the buttons you're pushing. You tell me you enter that equation in, so you hit y equals, you put the equation there. So second, trace 2 to find your 0. Left bound, just make sure you're on the correct side here. And I am. And then right bound, enter, and then hit enter again. And again, tell me all those different things. And there it is. So my x is equal to 3.322. Okay, so there it is, right? 3.322. So x equals 3.322. There you go. That's an approximate answer. Manually, do logs. So log of 2 to the x equals log of 10. All right, and then move the x in front, so x log of 2 equals log of 10. Okay, and then you can divide. So it's divide both sides by log of 2. So we get x equals log of 10 over log of 2. I can actually simplify it one more shot here. What's log of 10? Well, isn't log base 10 of 10? Well, that's actually equal to 1. So it's 1 over log of 2. And just for the heck of it, if I check it, let's go back to our calculator here. It's very friendly. 1 divided by log of 2. So 1, we got to get out of here. Quit. 1 divided by log of 2. Hey, 3.322. Very exciting. All right, so just 2 ways to do it. But again, when you're taking the AP exam, they might be looking for an exact answer. They may be looking for an approximate answer, and you have to know what you're doing. They might not let you use a graphing calculator or whatnot. All right, so just got to know what you're doing. All right, so let's see. I got 2 more graphs to do with you guys, and these are all pretty easy. 2e to the x minus 3 equals 10. Okay, so again, how do I do this with a graphing calculator? Move the 10 over so you get y equals 2e to the x minus 3 minus 10. Okay, so let's put that in our graphing calculator. So y equals 2 second ln. Okay, and then and you guys might have the new operating system, but that's fine. X minus 3. Don't forget to close parenthesis or end that exponent, and then minus 10. Okay, and then you hit zoom 6. There's your intercept there. So second, calculate 0, and kind of cursor over a little bit, enter, go to the other side, the right bound. Again, you're putting all these different things on your paper, right, saying what you're doing. Hit enter again, and then guess. So my answer is 4.609. 4.609. So let's write that down. 4.609. All right, that's cool. And how do you do it manually? Well, 2e to the x minus 3 equals 10. Divide everything by 2. So we get e to the x minus 3 equals 5. And then what do? Take the natural log of both sides, because we have an e. X, which is, what is e? 2.718. All right. So we take the natural log. That x minus 3 comes to the front. We get ln of e equals ln of 5. Well, what's ln of e? You guys should know that. That's actually equal to 1. Okay, so we have x minus 3 equals ln of 5, and we add, we add 3 to both sides. So we get x equals ln of 5 plus 3. So let's check out that value. I guess I hope it all works out here. Ln of 5. Oops, we need to quit out of here. Sorry. So ln of 5, close parenthesis, plus 3. Hit enter. 4.609. Let's see what we got here. Hey, there it is, man. Okay, so again, this is exact. That's decimal. All right. Last example. This has to do with our population growth, which you need to know. Okay, if I said 5,000 equals 2,800 times 1 plus 0.055 raised to the t power. Now, I'll tell you, if I asked you what everything meant, you guys should be able to tell me what everything meant, right? Like, this is population growth. This is my population after t years. This is my initial population. That's my growth rate which is 5.5%. And of course, that's your time. Time in years. Okay? All right, so again, if I do it with a graphing calculator, it's going to be y is equal to, graphing calculator is so easy, 2800, I'll just put this as 1.055 to the t power minus 5,000. It's so easy to do. Okay? And let's put that in our graphing calculator. So we get y, let's clear this out of here. Y is equal to 2800 times 1 plus 0.055. I could have put 1.055 too, right? Raised to the x power. Okay, and that's it. So, oh, I forgot, sorry. Raised to the x power. Minus 5,000. That's a pretty important thing to put in there. Okay, we're going to do zoom 6. All right, so you can see this is kind of out of the range here, right? So let's try a couple other things. How about zoom fit? Ah, very interesting. Okay, so you can see it's kind of fitting up here. Let's go to the window, because sometimes you want to maybe make the window a little bit so it kind of fits a little bit nicer. Looks like I need to make my X max a little bit bigger to fit in there. So I'm going to go 50. And let's raise up the whole thing, the Y value. So let's make that 200. And then graph. And yeah, there you can kind of see a little bit better, right? You can even make it a little higher, make the Y value. So sometimes you need to adjust your own window. Right, let's make this 2000. There, it's a nice, clean, much cleaner graph. I can see what the where the x-intercept is. So let's do second, calculate 0. We're going to go. Oops, I need to come back down here. So I'm looking at these values for left bound. I know I got to come down. There it is. So, kind of know your calculator. So here we're going to enter, and then go to the other side, hit enter, guess, and there's my answer. X equals 10.829. So let me shrink this down. So it's t is equal to 10.829, and then of course we're going to have years, right? We've got to have our units in here. Okay, and let's do it manually here. We are going to divide both sides by 2800. So we get log, oops, I don't want to take log yet. I get 1.055 to the t power equals 5,000 over 2800. Which I can cross those zeros out, right? 50 over 28, that's kind of nice. And then I'm going to take the log of both sides. So that goes in the front by your property of log. So t log of 1.055 equals log of 50 over 28. I can even simplify that if I want. And then my last step is to divide by log of 1.055. And that is actually your answer. That's an exact answer. Log of 50 over 28 divided by log of 1.055. But if I did that in our calculator, let's see what that is going to turn out to be. Okay, so let's quit out of here. Log of 50 divided by 28, close parenthesis, divided by log of 1.055. Okay, and we're looking for 10.829. Oh yeah, there it is, 10.829. Okay, so just kind of a good check. Just make sure we know what we're doing. So again, this is our approximate answer, and this is our exact. Okay. Anyway, that's it for day 6. And we're almost done with this chapter, but hopefully you guys learned a little bit about, even with parametrics, you learned about inverse functions, one-to-one functions, and a little bit more about solving equations using logs. All right, that's it, math fans. Have a great day, and good luck with the snowstorm. Adios. Goodbye.